Understanding Cloud Computing Services. About this course. Welcome to the Understanding Cloud Computing Services course. In this course, you'll get an overview of how the cloud supports and powers new technologies like artificial intelligence, AI, and the Internet of Things, IoT. You'll learn about the four main types of cloud service models and two types of software approaches when it comes to cloud solutions, proprietary and open source. You'll get to explore the services offered by the major cloud providers, IBM Cloud, Microsoft Azure, and Amazon Web Services. And finally, you'll learn through some scenarios about the advantages and value businesses and individuals can expect when they use the various cloud service models. Learning objectives. After completing this course, you should be able to describe the characteristics of various cloud service models, including IaaS, SaaS, PaaS, and DBaaS. Differentiate between proprietary and open source approaches for developing cloud solutions. Identify the services and differentiators of the major cloud providers. Identify scenarios where various cloud service models are appropriate to use and recognize the value that businesses can expect from them. Module 1. What are cloud services and how are they modeled? Introduction. In this module, you'll learn ways the cloud enables up-and-coming technology like artificial intelligence, AI, and the Internet of Things, IoT. You'll also learn about the four types of cloud service models: software as a service, SaaS, infrastructure as a service, IaaS, platform as a service, PaaS, and database as a service, DBaaS. And, find out how businesses and users can use these models in a variety of computing environments. Learning objectives. After completing this module, you should be able to describe how the cloud enables AI and the IoT. Explain the four types of cloud service models: software as a service, SaaS, infrastructure as a service, IaaS, platform as a service, PaaS, database as a service, DBaaS. A look to the future. In recent years, many businesses have been moving their operational work to the cloud. For example, businesses might store their employee data and use that data to run payroll systems in the cloud. An individual computational task like running payroll is called a workload. Moving common workloads to the cloud enables businesses to save money, scale based on business needs, accelerate innovation. As companies look to the future, the cloud provides them with exciting new opportunities. Imagine a delivery company that delivers packages using drones or autonomous vehicles. Consider an automotive company that develops cars that use machine learning to interact with drivers and passengers, and communicate with pedestrians and traffic lights in real time. The cloud enables these scenarios and many more. Artificial intelligence in the cloud. In the 1950s, computer scientist and mathematician Alan Turing developed a test to determine if a computer was thinking similarly to the way humans think. The test was simple: if 30% of humans who conversed with the machine couldn't tell if it was a machine or a human, the machine passed the test. The test became known as the Turing test, opens in a new tab. It took until 2014 for computer engineers to develop a computer that could pass the test. Diagram showing how the Turing test works. One tester at the bottom of the diagram converses with both a computer shown at the top left and a human shown at the top right. Screens between the tester, computer, and human mean that the tester does not know whether he is conversing with the computer or the human. Machines that can process information in a way that mimics or imitates human thinking are said to be intelligent. Because the intelligence isn't human, scientists have called this kind of thinking ability as artificial intelligence, AI. The many faces of AI. Popular and academic groups have been discussing AI for decades. But it's recently become mainstream largely due to the advances in cloud computing. AI is a term that encompasses a broad range of technologies. Image recognition is used in medical diagnosis, where doctors rely on AI to analyze medical images and patient data to improve the accuracy of identifying health issues and planning treatments. It is also applied in national security, helping agencies recognize faces in security footage so they can identify individuals and detect potential threats. Natural language processing powers virtual assistants like Siri and Alexa, enabling them to understand human speech and improve how they interact with users over time. Businesses also use NLP in chatbots to provide real-time customer support, allowing the bots to learn and respond more effectively. Real-time data analysis is used in gaming, where AI helps games adapt to a player's behavior and create more dynamic experiences. Deep learning supports recommendation systems by analyzing customer behavior and generating personalized suggestions, as seen with platforms like Netflix and Amazon. It is also used in fraud detection, where AI algorithms identify unusual patterns in data to spot fraudulent transactions and help customers recover from unauthorized charges. How the cloud enables AI technology. The ability to create powerful artificial intelligence has accelerated as cloud systems have evolved. Here, you can explore the ways cloud technology enables AI, and you can think about new AI scenarios the cloud will power in the future. Data storage. Most AI systems operate using a lot of data. For example, a natural language processing (NLP) system uses large volumes of data to learn the structure of a language. The system then learns how to construct sentences in that language from the existing narrative text. Because training machine learning models requires vast amounts of data, the cloud provides much easier access to terabytes of sample data from all over the world. Processing power. To process large amounts of data quickly, AI systems need high-powered central processing units, CPUs, and the ability to scale up with more power as they need it. The millions of CPUs the cloud provides along with the scalability of the cloud gives engineers the power they need to build accurate AI systems that work quickly. High availability. The cloud is a global network of connected computers. The computers that comprise the infrastructure of the cloud are only one part of that network. Individual devices use cloud services to make even low-powered devices more powerful. If you ask a question of the digital assistant on your phone, it uses the cloud to process your request and send back an answer in real time. This is only possible because the cloud is always available and ready to service users anytime and anywhere. Experimental opportunities. Individual companies often find it difficult to add experimental hardware and software to their offerings. However, this becomes much easier when using cloud providers who have the resources of thousands of companies and users. IBM quantum computers are an example. Even small companies can use the power of these computers, something that wouldn't be possible without the cloud. Reflection: what do you think? You've learned about some examples of ways the cloud has powered artificially intelligent systems. Can you think of other applications for artificial intelligence and suggest ways the cloud can power those applications? You might include in your thinking ways that humans interact with each other in which artificial intelligence can support or enhance. Evaluate your thinking. Does your answer account for the following? AI doesn't always replace human interaction. Many times it can enhance ways humans interact. For example, a video chat tool might have an AI transcriber that converts voice to text. A video or chat message would be uploaded to the cloud, translated using AI, and then both the original message and the transcription would be saved in the cloud. This type of AI, and the cloud services used to make it possible, can make documentation, translation, and note-taking easier. The Internet of Things. In 2016, researchers at the Massachusetts Institute of Technology, MIT, imagined a scenario where vehicles can safely move through a four-way intersection without stopping. The striking concept was called slot-based intersections, and they conceived of vehicles being able to communicate with each other so they could inform other vehicles where they were and grab a slot through the intersection. But this concept wouldn't be possible without the cloud. In 2018, the Institute of Electrical and Electronics Engineers, IEEE, expanded the idea and developed models for how it would work. Take a moment to review the steps the vehicles would take. Step 1. Every vehicle calculates its distance to the intersection, along with the distance of the vehicles approaching from different directions, as well as their own speed, acceleration, and trajectory. Collectively, they choose a leader vehicle to lead for a specific duration. Step 2. The leader vehicle determines which direction has the priority to proceed, like a green light, and which direction must stop, like a red light. Step 3. The leader vehicle designates its own direction of movement as having a red light status, while granting the green light to all the vehicles traveling along the cross street, or perpendicular flow. Step 4. Once the leader's turn is complete, a vehicle in the perpendicular flow takes over as the new leader and performs the same actions. This process of transferring leadership is repeated, and that is all the algorithm requires to determine which vehicle has the right of way, green light, and which vehicle must stop, red light, at the intersection. Sources opens in a new tab. When slower is faster, opens in a new tab. MIT News, by Peter Daszak, March 2016, opens in a new tab. How vehicle-to-vehicle communication could replace traffic lights and shorten commutes, opens in a new tab. IEEE Spectrum, by Ozan K. Tungus, September 2018. What does this automotive scenario have to do with the cloud? Explore the next section to learn more. Connecting devices to the Internet. Although the scenario described by MIT and IEEE might seem like science fiction, the technology to enable scenarios like these already exists, thanks in part to the cloud. For vehicles to behave in the way these organizations describe, they need to communicate with each other and to perform complex calculations in real time. The cloud supports communication between devices and hosts the computing power for performing complex calculations, so the vehicles just need networking devices that can send specific and large amounts of data to the cloud. Connecting devices to the Internet and to each other using the cloud is called the Internet of Things, IoT. Data. The cloud collects, analyzes, and transmits data from a variety of sources, enabling vehicles to share and access information from sources such as traffic conditions, weather forecasts, and road hazards. Sensors. Vehicles and roads fitted with sensors send and receive data using Wi-Fi, satellite, or cellular connections to the cloud in order to communicate with each other and cloud servers. Onboard computers in the vehicles and computers in the cloud analyze the data using machine learning. This enables vehicles to optimize their performance, safety, and efficiency. Status. Utilities such as traffic lights and street lamps use cloud-connected sensors, timers, and efficiency equipment to optimize how they operate. For example, a street lamp might turn off when no vehicles or people are nearby and turn on when a pedestrian or passing car needs light. The cloud. The speed, availability, and computing power of the cloud makes all this possible. Advanced services like machine learning can make analyzing large amounts of data useful and provide valuable information to devices that need it. The IoT is a networking model that describes the interconnection of physical devices, appliances, and everyday objects that owners can access and control through the Internet. These devices are equipped with sensors, software, and network connectivity, enabling them to collect and transmit data to other devices, applications, or cloud-based services. Think of it as a network of connected objects that can communicate with each other, even if they are in different parts of the world. For example, a smart thermostat in your home can communicate with your phone and enable you to adjust the temperature in your house while you are overseas. Or a smartwatch can track your activity data and send it to an app on your phone. The cloud and IoT. The cloud plays a crucial role in enabling the IoT by providing a platform for storing, processing, and analyzing the massive amounts of data generated by IoT devices. Data and analytics. IoT devices collect data and send it to the cloud where services store, process, and analyze the information. Other cloud services can use the data to derive insights and make informed decisions, such as identifying patterns, detecting anomalies, predicting maintenance needs, and optimizing performance. Scale and flexibility. The cloud also provides a scalable and flexible infrastructure for deploying and managing IoT applications and services. Developers can use cloud-based tools and platforms to create and deploy IoT applications and manage them for large-scale deployments. Security and compliance. In addition, the cloud provides a secure and reliable environment for storing and transmitting sensitive data generated by IoT devices. Devices and cloud services can encrypt data and control access to it using role-based access control. Engineers can create IoT applications and services without a heavy reliance on the cloud. However, in order to develop large-scale IoT deployments or services that require a lot of processing power and storage, the cloud is essential. AI and the IoT applications and services are just two examples of services that the cloud empowers, due to their intensive need for large data sets and processing power. The structure of cloud services, or its service models, creates an environment for businesses and users to create and use services like these. Next, you'll explore more about the cloud service models and ways they help people do more with technology than ever before at a lower cost and with less management. The cloud service model. People that work with and use cloud services have become familiar with the phrase as a service. The phrase describes one of the biggest shifts in cloud computing. That shift involves moving computing from individual computers with software installed on them to a network of computers with a variety of software options that people can use as they need them. For instance, the Microsoft Corporation delivers its widely used Office suite of products as a service. Traditional software. Office productivity tools such as Microsoft Office were pre-installed on a computer or purchased separately and then installed. Users downloaded the software and it installed locally, either from a CD-ROM or from the internet. Users purchased the software one time and, occasionally, new versions needed to be purchased, downloaded, and installed. Software as a service. Using the cloud, a person can use Microsoft Office without needing to download or install anything through the software as a service model. They can use it on any number of devices including mobile phones and tablets. Users purchase software through a subscription service which is continually updated. Types of cloud service models. Cloud providers might apply the as-a-service name to a variety of offerings. However, there are four main types of service models that you need to know. Take time to explore each service model and note how they are similar and different from each other. Software as a service, SaaS. SaaS is a way of delivering software applications to users over the internet without requiring them to install or manage the software themselves. Instead, servers host the software in the cloud and users can access it through a web browser or internet-connected device. Think of it like renting a car instead of buying a car. When you rent a car, you don't have to worry about maintaining it or paying for repairs, because the rental company takes care of all that for you. In the same way, when you use a SaaS application, you don't have to worry about installing or maintaining the software, because the provider takes care of all that for you. With SaaS, users pay a subscription fee to access the software, usually on a monthly or yearly basis. This fee covers the cost of hosting the software on the provider's servers, as well as any updates or new features that are added over time. Infrastructure as a Service, IaaS. IaaS is a cloud computing service model that provides users with access to computing resources over the Internet. These resources include servers, storage, and networking components, which are all hosted by a cloud service provider. Think of it like renting office space instead of buying your own office. When you rent office space, you don't have to worry about building or maintaining the building, because the landlord takes care of all that for you. In the same way, when you use IaaS, you don't have to worry about building or maintaining computing infrastructure, because the provider takes care of that for you. With IaaS, users only pay for the computing resources they use. This means they can easily scale their usage of these resources up or down depending on their needs, without having to worry about investing in expensive hardware or IT infrastructure. Platform as a Service, PaaS. PaaS is a cloud computing service model that provides users with a platform to develop, run, and manage applications over the Internet. With PaaS, developers don't have to worry about managing the underlying infrastructure or operating system, because these are all taken care of by the third-party provider. Think of it like renting a fully equipped kitchen instead of building your own. When you rent a fully equipped kitchen, you don't have to worry about buying or maintaining the appliances, because the kitchen comes fully equipped with everything you need to cook. Similarly, with PaaS services, the platform comes fully equipped with everything an engineer needs to develop and run their applications. As with IaaS, users only pay for the platform services they use. Database as a Service, DBaaS. DBaaS is a cloud computing service model that provides users with access to a fully managed database. With DBaaS, users don't have to manage the underlying infrastructure or database software. The cloud provider is responsible for ensuring these are available and operating properly. Like SaaS, IaaS, and PaaS, DBaaS is similar to renting rather than buying in that the service provider takes care of all the maintenance and infrastructure, so you don't have to. The provider takes care of all the database management tasks, such as provisioning, backup, and recovery, as well as patching and upgrading the software. With DBaaS, users pay for the database and the computing resources they use on a pay-as-they-go basis. This means they easily can scale up or down their usage of the database and resources, depending on their needs, without having to worry about investing in expensive hardware or IT infrastructure. Service models working together. People can use the 4 cloud service models in isolation or together to create a cloud-based solution. Here's a quick overview of how they work together. IaaS and DBaaS provide the foundational layer of computing resources, including servers, storage, and networking components. PaaS builds on top of IaaS and DBaaS by providing a platform for developing, running, and managing applications. SaaS works in conjunction with PaaS by providing access to software applications over the Internet, without users having to install or manage the software locally. Migrating to the cloud. In a cloud-based solution, IaaS, PaaS, SaaS, and DBaaS can work together to provide a complete cloud computing ecosystem. Imagine an independent laboratory that tests water samples for contaminants from locations around the world. Their business is growing and they want to migrate to the cloud. Explore the following timeline to learn more about their approach to the migration and how they use the cloud to expand their business. Migrating infrastructure and data to the cloud. The laboratory uses IaaS and DBaaS to host their infrastructure. They move all their data to a cloud database which will expand as needed as the lab continues to grow. They move key software to cloud servers and decommission their in-house servers and recycle them for other purposes. Moving key applications to the cloud. The lab runs customer software that increasingly requires more processing power to analyze data. They migrate this software to a PaaS solution in the cloud which enables them to expand their software and its capabilities without having to purchase and manage their applications. Moving workstations to the cloud. By using their cloud provider's SaaS offerings, the laboratory can create Linux and Windows workstations in the cloud so their scientists can access virtual computers from any device and any location. The lab can now easily scale their IT systems as they grow and support their scientists to work from anywhere around the world. About this module. Module 2. Proprietary and open source software. Introduction. In this module, you'll learn about 2 types of software distribution and development approaches, proprietary and open source. You'll also explore why cloud developers might use one or both of these approaches when developing software solutions for the cloud. Learning objectives. After completing this module, you should be able to differentiate between proprietary and open source software. Identify circumstances in which developers use proprietary and open source software to develop cloud solutions. 2 types of software. Suppose you spend some time learning how to grow vegetables, herbs, and flowers and become talented at growing them. You then decide to earn a living by planting a garden and selling your produce. You start with a small garden and sell to neighbors and friends. Over time, you expand your garden and you sell to local grocery stores and restaurants. You've used your gardening skills to create a business and can use the money from selling produce for anything you like. The garden is a means to other ends. Now imagine you join a community garden where everyone in the community is free to pick any vegetables, herbs, and flowers from the garden that they want whenever they like. In exchange, each person agrees to tend to the garden by picking weeds, adding new features like fences and walking paths, and occasionally planting new seeds to make the garden better for everyone. The garden is a means to provide fresh produce to people in the community. Like the gardeners, developers create and use software in various ways and for different ends. The two main types of software are proprietary and open source. Proprietary software is like the first example of growing and selling your own produce. Open source software is like the second example of supporting a community garden. Proprietary software refers to computer programs that a specific company or individual own and control. These programs usually are developed by a team of software engineers. They are protected by intellectual property laws. This means that their source code is kept confidential and not publicly available. The companies that create proprietary software usually sell licenses to use their software to individuals or other companies. The licenses might have specific terms and conditions that dictate how the purchaser can use, modify, or distribute the software. These terms often require users to pay for use of the software and might limit the number of devices or users that can access the software. Open source software is computer software that developers create and distribute under a special type of license that allows users to freely access, modify, and distribute the source code of the software. This means that anyone can view and change the underlying code of the software provided they comply with the terms of the license. Unlike proprietary software, open source software developers often work collaboratively as a community of programmers and developers who share their work and contribute to each other's projects. Open source software is often available for free, although some open source projects might ask for donations or have other ways to support their development. Reflection: what do you think? The gardening examples compare how two types of gardens, a private garden and a community garden, can serve different purposes. Proprietary and open source software also can serve different needs based on the situation. What is one reason you can think of for why a software developer would use open source software to develop services on the cloud? Evaluate your thinking. Does your answer account for the following? Using open source means that the software developer doesn't have to create all their service features from scratch. Means that the software developer can customize existing code for their specific needs. Is often less costly than proprietary software. Next, you'll learn more about different situations in which software developers use open source and proprietary software to develop cloud solutions. Software on the cloud. Software developers use both proprietary and open source software when developing cloud solutions. They usually base their choice of software type on the situation they're trying to address and whether there is open source software available to address it. Let's explore this in more depth. Proprietary software. Developers encounter many circumstances where working with proprietary software is appropriate. For instance, in specialized industries, such as aerospace and defense, proprietary software might be the only option. Select each section to learn more about when developers use proprietary software for cloud solutions. Interoperability. Sometimes a software developer might be working on software that uses other proprietary tools or software products that are unavailable in the open source ecosystem. In such cases, using proprietary software is necessary to ensure compatibility and interoperability with the existing tools and technologies in the software solution. Security requirements. In environments where security is a top concern, software teams might not have the resources to review every line of code in an open source package to ensure that it meets their security requirements. Developing software from scratch enables software teams to have specific knowledge of and take responsibility for all the code they deliver to the customer. Alternatively, a development team might purchase proprietary software from a reputable company that guarantees the software's security. Legal compliance. Proprietary software is typically distributed under a license that defines how the purchaser can use, modify, and distribute it. By using proprietary software, developers can ensure that they are compliant with licensing terms and avoid any legal issues related to copyright or intellectual property. Specialized features. Sometimes advanced features and functionalities are not available in open source software. If a software developer needs access to such specialized features, proprietary software might be their only option. Quality and support. In situations where a business or individual buys rather than builds software, proprietary software is often backed by a dedicated team of developers who provide regular updates, bug fixes, and technical support. This can provide assurance to the purchaser that they will receive timely assistance if they encounter any issues or errors with the software. In many cases, developers will write their own proprietary software, but adorn or enhance it with open source code. Open source software. Although proprietary software is necessary in a variety of situations, increasingly many teams are turning to the open source community for software that can help them build their cloud solutions. Some teams use open source software exclusively and modify it to fit their needs. Other teams supplement their proprietary software with open source. Some cloud solutions that providers offer are based on open source software. Although large companies can use open source software to build their cloud infrastructure, individuals and smaller companies can also use it to build their own cloud. These clouds typically are built for the individual or company alone to use and aren't publicly available. This type of cloud is called a private cloud. Under which circumstances is open source the best option? Select each section to learn more about when developers use open source software for cloud solutions. Lower costs. Open source software is often available for free, which can be a major cost-saving factor for individual developers or small companies with limited budgets. Even for larger organizations, open source software can provide cost savings compared to proprietary software that requires licensing fees. Collaborative environment. Open source software development often involves a community of developers who contribute to the project and provide feedback, bug fixes, and updates. This creates a collaborative environment that fosters innovation and encourages the sharing of knowledge and ideas. Even if a business has their own software development team, the open source community is very large, and having more contributors can mean the company can develop solutions and solve problems more quickly. Transparency. In situations where a company or individual is unable to develop their own software, open source software is publicly available and the source code is accessible. This enables the developer to review the code to ensure that it is secure and free of potential vulnerabilities that might compromise their systems or data. Customizability. Open source software provides access to the source code, which enables developers to customize and modify the software to meet their specific needs. This can be particularly beneficial for developers who require specific functionality or features that are not available in off-the-shelf software products. Uniformity. Users often benefit from the availability of similar features across various software products that they use. For example, menu functionality, button images, scrolling behavior, and even ways that products interact and process data. Open source software can provide this uniformity and predictability for developers so their users don't need to spend time learning proprietary software that behaves differently than their existing software. Both proprietary and open source software have their places on the cloud. When to use each type of software and why is a decision that cloud development teams must make when they're creating their solutions. Teams often choose proprietary software for security and legal reasons or when they need specialized features in their solutions. But open source software has changed the software industry in significant ways. It provides developers with the resources they need to rapidly build and expand the power of the cloud. About this module. Module 3. Overview of cloud service providers. Introduction. This module gives you an overview of some of the major cloud providers that individuals and businesses use. You'll learn about the unique features these companies provide and explore the solutions people are developing with them. You'll also learn how open source cloud software helps individuals and businesses to develop their own clouds and why people use open source cloud software. Learning objectives. After completing this module, you should be able to identify common cloud features that cloud providers share. Describe IBM Cloud. Describe Microsoft Azure Cloud Services. Describe Amazon Web Services, AWS. Recognize options and considerations for an open-source cloud. Thinking about who provides the cloud. Asking who operates or manages the cloud is like asking who operates or manages the Internet. No single individual or company is responsible for managing the cloud. Although the Internet is made up of millions of devices connected through a global network, the computers and services that make up the cloud are more narrowly focused on data storage, management, and processing, remote computing, and the creation and delivery of software and services. The cloud refers to a collection of remote servers that users access over the Internet. They use them to store, manage, and process their data, do things like operate a website, and perform computing functions like running calculations. Basically, the cloud is a virtual space where they can store and manage data, use computer resources, and perform computing tasks without having to use their own physical computers. One way to think about it is that the Internet is like a highway, connecting people and devices all over the world, while the cloud is like a warehouse, providing a place to store and access data, use remote computers, and develop and use services over the Internet. Cloud providers build the devices and services that are resilient to downtime and attacks, as well as the scalable cloud services that large businesses need. This requires a lot of investment in time and money. Because of this, most cloud service providers are large companies that have the resources to invest. In this module, you'll explore the features of the major cloud offerings from IBM, Microsoft, and Amazon, as well as learn about the features of open-source cloud software. Features cloud providers share. When businesses compete in a similar space, a company might work to differentiate themselves from their competitors by offering products or services that others don't. This certainly is true in the cloud provider business. However, the major cloud providers offer many similar services and infrastructure features. They might differ somewhat in the details, but in general cloud providers need to have certain features in place to appeal to users and businesses. Select each section to learn more about features that all major cloud providers share. Global presence. All major cloud providers have data centers across the globe. For example, Amazon Web Services, AWS, has 99 data centers in 31 regions around the world. The closer data centers are to users, the faster and more reliable the cloud experience will be. Strong security. All cloud providers encrypt data and use monitoring software and hardware to detect threats. They also use the latest technology for managing access to resources such as hardware access keys and multi-factor authentication, MFA. Reliability. Cloud providers use redundant systems to ensure data and services are available when users need them. For example, Microsoft Azure has a service level agreement measured in 9S. Their entry-level offerings have a guaranteed uptime of 99.9% of the time, 3 nines. For businesses that need even more reliability, they offer services with up to 11 nines or 99.999999999% uptime guarantees. Scalability. All cloud providers offer scalable solutions to meet the changing needs of businesses. Users can add or remove computing resources quickly and when they need them or no longer need them. Standard services. All the major cloud providers offer a wide range of standard services, including Infrastructure as a Service, IaaS, Platform as a Service, PaaS, Software as a Service, SaaS, Database as a Service, DBaaS. Competitive pricing. Each cloud provider offers various pricing models to meet the needs of their users. Pay-as-you-go and subscription pricing is standard for all the major cloud providers. Providers also enable customers to pay for the amount of a given service that they use. For example, data storage might be priced per gigabyte. Pricing is roughly the same across providers for similar services. When choosing a cloud provider, businesses will find that most providers deliver similar services and infrastructure on which they can build their cloud solutions. Some businesses might need specialized services though, and this is where one cloud provider might stand out over others. IBM Cloud. A server room, with the central aisle of light-colored cabinets and cages of black cabinets on either side. Suppose your company built its own data center decades ago and it has served them well. The company's technical advisors have been looking at the cloud and have even adopted some cloud services like data storage but haven't made a major transition to the cloud. They have concerns related to sensitive customer data and legacy systems that rely on special hardware in their data center. They decide that they need a hybrid solution, a way to keep some of their legacy systems integrated into their technology, but also start to take advantage of some of the best of what the cloud has to offer. For a scenario like this, the IBM Cloud offering is a great place for your company to start. IBM Cloud Services provide most of the same services that customers can find at other cloud providers. However, IBM differentiates itself in three main areas: hybrid cloud, artificial intelligence, AI, and natural language processing, NLP. Emerging quantum computing technology. I want our partners to be the best at establishing a hybrid cloud architecture and an AI footprint at our clients. Arvind Krishna, opens in a new tab, Chairman and Chief Executive Officer, IBM. IBM Hybrid Cloud. A hybrid cloud is a computing environment that combines the use of public cloud services and private cloud infrastructure. Organizations can take advantage of the benefits of both. In a hybrid cloud environment, some workloads and data are kept in a private cloud, or on-premises infrastructure, and others are moved to the public cloud. The two environments are connected and can communicate with each other. This enables businesses to scale resources up or down depending on demand, while maintaining control over sensitive data and applications. IBM Hybrid Cloud consists of a range of technologies that support the infrastructure deployment. Architecture. The IBM Hybrid Cloud architecture is designed to integrate on-premises infrastructure with public cloud services, and it's built on a foundation of open-source technologies. Kubernetes. Developers use Kubernetes to automate the deployment, scaling, and management of solutions that use containers. The IBM Kubernetes offering is a special platform that helps businesses securely and easily manage their containerized applications. In a hybrid cloud environment, Kubernetes can help businesses manage containers in the public cloud and on on-premises servers, seamlessly integrating between the two environments. OpenShift. OpenShift is a cloud computing platform that businesses use to develop, deploy, and manage their applications. It is an open-source, container-based platform built on top of Kubernetes and Docker. OpenShift provides a comprehensive set of tools and services for developers, operations teams, and IT administrators to streamline the application development process. IBM Cloud Pak for Applications is the OpenShift offering from IBM. Pricing model. IBM Hybrid Cloud has a flexible pricing model that allows customers to only pay for what they use. IBM Cloud Code Engine. IBM Cloud Code Engine is a fully managed serverless platform that enables developers to quickly deploy containerized applications and functions to the cloud. It provides a platform for running and scaling applications without the need to manage servers, containers, or infrastructure. IBM Cloud Code Engine also provides integration with other IBM Cloud services, such as IBM Cloud Object Storage, IBM Cloud Databases, and more. This integration enables developers to easily build and deploy applications that leverage other IBM Cloud services. Analytics and Artificial Intelligence. The IBM Analytic and AI offerings enable businesses to leverage data-driven insights and optimize operations in a hybrid cloud environment. By integrating and analyzing data from multiple sources, businesses can gain valuable insights into their operations and customer behavior. AI tools like IBM Watson can help automate processes and improve customer engagement through personalized recommendations and conversational interfaces. Additionally, the IBM Analytic and AI offerings include advanced security features that help protect businesses from cyber threats and ensure compliance with regulatory requirements. IBM Artificial Intelligence and Natural Language Processing. IBM has invested heavily in research and development of AI and NLP technologies, and its cloud offering stands out in these areas. IBM Watson technology has been at the forefront of the evolution of artificial intelligence, and the technology is available to IBM Cloud users. IBM Watson. IBM Watson is at the core of the IBM AI and NLP offerings. It's a suite of AI tools and services that leverage NLP, machine learning, and deep learning to help businesses analyze large amounts of unstructured data and make more informed decisions. Select each section to learn more about the core features of IBM Watson services. Language services. IBM Watson offers a suite of language services that enable businesses to analyze and understand text and speech data. The services include language translation, natural language processing, sentiment analysis, vision services. Vision services use image recognition and computer vision to analyze and understand visual data. The services include object detection, face recognition, image classification. Speech services. Speech services enable businesses to transcribe and analyze speech data. The services include speech-to-text conversion, speaker identification, emotion detection. Knowledge services. Knowledge services are a set of services that help businesses manage and analyze structured data. The services include data exploration, predictive modeling, data visualization. Assistant services. Assistant services enable businesses to build chatbots and virtual assistants to interact with customers and employees. The services include tools for chatbot design, integration with business systems, natural language processing. Discovery services. Watson Discovery services enable businesses to search and analyze large amounts of unstructured data, such as documents and emails. This includes text mining, entity extraction, concept tagging. Watson Studio. Watson Studio is a collaborative environment for building, training, and deploying machine learning models. It includes tools for data preparation, model development, deployment. IBM Watson tools offer a comprehensive suite of AI services that can help businesses make sense of large amounts of data and improve their decision-making. IBM Quantum. IBM has been at the forefront of quantum computing and undertakes unique research while working hard to make the technology practical. Quantum computing is a new way of creating computers that can solve the very hard problems that traditional computers cannot. Quantum computers use tiny particles called qubits. Qubits are the basic units of quantum information. Unlike normal bits that can only be either 0 or 1, qubits can be in two states at the same time. This gives quantum computers more power and speed to perform complex calculations. An inside view of a quantum computer. Quantum computers can help scientists do things like design new drugs, break secret codes, and understand the universe better. However, quantum computers are still very hard to build and use, because qubits are very sensitive and can lose their special properties easily. Scientists at IBM are working to create better qubits and quantum algorithms to make quantum computing more practical and useful. Quantum computing in the cloud. IBM Cloud provides access to real quantum hardware and simulators. Users access the quantum devices through the IBM Quantum Platform, which offers a virtual interface for coding a real quantum computer through the cloud, and Qiskit, the IBM open-source quantum software development kit. IBM first made these quantum computers available in 2016. Since then, users have executed more than 30 million experiments across the hardware and simulators on the Quantum Cloud platform and published over 200 third-party research papers. Select each card to investigate scenarios where quantum computing is impacting research and computing in general. Healthcare. A healthcare company is using the IBM quantum computers to improve patient care and reduce costs by optimizing provider networks, personalizing treatments, and detecting fraud. Automotive. IBM is working with automotive companies who are using the quantum computers to design better electric vehicles by developing new battery materials, optimizing charging stations, and reducing emissions. Energy. Oil and gas companies are using IBM quantum computers to solve complex problems in energy production and distribution, such as optimizing maritime logistics, modeling chemical reactions, and exploring new sources of energy. Science. CERN, the European Organization for Nuclear Research, is using the quantum computers to study the fundamental particles and forces of nature, such as the Higgs boson and the origin of the universe. The IBM Quantum Cloud is very specialized and continues to evolve. It represents a powerful new frontier in cloud computing and will open opportunities for new applications and services that aren't possible with traditional computing. Explore more. Check out these resources. IBM Cloud Documentation opens in a new tab to view the latest product information, tutorials, and resources that users and businesses access for IBM Cloud. What is hybrid cloud? Opens in a new tab by IBM to learn about how hybrid cloud works. What is quantum computing? Opens in a new tab by IBM to learn about this rapidly developing technology and its potential to change the world. Microsoft Azure. Microsoft Corporation launched its cloud service, called Azure, in 2008 to help people and businesses make websites and apps without writing a lot of code. It was a competitor to other similar services, such as Amazon EC2 and the Google App Engine. It became available for everyone to use in 2010. It was originally called Windows Azure, because it was based on the Windows operating system that many people use on their personal and business computers. A group of 4 people working together in an office. In 2014, Windows Azure changed its name to Microsoft Azure to show that it can do more than build tools with Windows. It provides a wide range of services for different needs and preferences. Over time, Microsoft Azure offered more options and features, such as supporting more of the languages, programs, and systems that software developers use. It added an option to use Linux-based computers. Linux is a non-Windows-based system that some people prefer to use. Azure delivered faster internet communication by locating data closer to where the users are. It also added more ways to connect different types of software and systems together. Today, Microsoft Azure provides more than 600 different services for its users. Microsoft Azure offerings. Azure has similar features to other cloud providers, but differentiates itself in specific areas, such as strong enterprise or business support and product integration. Strong enterprise support. Microsoft has had a long relationship and focus on the enterprise, or business, customer. Azure continues this tradition with a strong reputation for enterprise support, including features like 24/7 customer support, service level agreements, SLAs, and compliance certifications. Product integration. Azure integrates well with other Microsoft products like Office 365, Dynamics 365, and Visual Studio. This makes it easier for businesses that already use these products to adopt Azure. Large partner ecosystem. Azure has a large partner ecosystem, including independent software vendors, ISVs, system integrators, SIS, and managed service providers, MSPs, providing customers with a wide range of options for support and services. Dedicated gaming cloud service. Azure provides a dedicated gaming cloud service called Azure Play Fab. This helps game developers create, launch, and operate live games with a global scale and reach. Developers can use Azure Play Fab to build cross-platform games, manage live operations, monetize their games, and engage their players. Developers, business users, and users. Azure is heavily focused on enabling software developers to build cloud-based solutions. Microsoft's cloud also supports cloud-based software, such as Microsoft Word and Excel, which business and personal users across the world can use. This is an example of software as a service, SaaS. Review this example of how a person can use Microsoft Cloud products. This is a day in the life of Kimberly, an employee at a bank in her town. She uses Microsoft Cloud products for many activities throughout her day. 7 a.m. Wake up. Kimberly uses the Microsoft Office suite on the cloud and sets an alarm in her mobile phone's calendar that wakes her up so she can get ready for her day. 8 a.m. Online meeting. Before she drives to work, Kimberly joins an early remote meeting. She uses Microsoft Teams software to stream audio and video and uses a digital whiteboard to illustrate some ideas for her team. Teams uses the Microsoft Cloud to power these experiences. 9 a.m. Email time. Kimberly arrives at work and begins her day by checking email using Outlook, the Microsoft email client. Kimberly accesses Outlook from her browser and uses the Microsoft Cloud Services as its engine. 11 a.m. Writing a report. Kimberly needs to do some research to create a report that her manager requested. She uses Bing Chat, a Microsoft AI-powered search engine that uses NLP to answer some questions for her report. 2 p.m. Finding a document. In the afternoon, one of Kimberly's team members asks her for a document she created a few months ago. She searches her personal OneDrive, a Microsoft cloud-based storage service, to find the document. She shares the document with her coworker directly from the service. 6 p.m. Unwind from the day. After dinner, Kimberly wants to unwind, so she plays online games on her Xbox, which is the Microsoft gaming console, and streams games from the Microsoft cloud-based gaming service. The Microsoft Cloud empowers developers, business users, and users to build and use powerful productivity software, access media and files from anywhere, and even enjoy entertaining experiences. Azure and the Microsoft Cloud software are platforms on which users can build a variety of solutions and experiences. Explore more. Check out these resources. Opens in a new tab. Azure Documentation opens in a new tab to view the latest product documentation, tutorials, and resources that users and businesses access for Microsoft Azure. Get started with Azure opens in a new tab to explore Azure Cloud Computing Services, find how-to videos, and more. Cloud Computing Terms opens in a new tab by Azure to access a list of terms and definitions with opportunities to learn more. Amazon Web Services. Amazon Web Services, AWS, is the largest provider of cloud services to developers and businesses. The Amazon Cloud Service is comprehensive and has the features and services found at other major cloud providers. Amazon differentiates itself from other providers largely because it has a larger user base than other providers, which has created a large community base. Amazon's core business, online retail, has enabled it to gain core expertise in analyzing enormous amounts of customer and retail data. Amazon developed the tools it uses for its business and used the expertise of these tools to inform how to build its customer-facing cloud software. It also supports a range of technologies enabling users, from hobbyists to seasoned software developers, to use the platform regardless of what technology they've chosen to use. Networking and content delivery. AWS content and analytic tools are services that help customers store, process, and analyze data on the cloud. Review this example of how a person can use AWS cloud tools. Kenji is a blogger who writes about current events in the news and happenings around his city. He's answering some questions to share with you how he uses AWS to create his content and analyze user interactions with his content. Why do I use AWS? I love being a blogger. It gives me the freedom to express myself and connect with people who share my passions. But blogging is not easy. It takes a lot of work and skill to create and maintain a successful website. That's why I use AWS, the cloud computing service from Amazon. AWS helps me with every aspect of my blogging journey, from designing my website to analyzing my performance. My website is fast and scalable. Since I host my website on AWS, that means that it runs on servers located in different places around the world. This makes my website fast, reliable, and secure. I don't have to worry about downtime, hackers, or losing my data. AWS also enables me to adjust the resources I need for my website depending on how many visitors I have. This way, I only pay for what I use and I can handle any spikes in traffic. My content engages visitors. But having a website is not enough. I also need to create content that attracts and engages my audience. AWS helps me with that too. I use AWS to produce different types of content, such as videos, podcasts, and interactive quizzes. AWS has tools that let me edit, upload, and stream my content without any hassle. If I want, I can also use AWS to add more features like a chatbot, voice assistant, or personalized recommendations to my website. These features could make my website more interactive and fun for my visitors. My data provides insights. Of course, I also want to know how well my website and content are doing. AWS helps me with that as well. I use AWS to collect and analyze metrics, such as page views, comments, shares, and subscriptions. AWS gives me dashboards and reports that show me how my audience is responding to my content and what they are interested in. AWS also helps me to optimize my website and content based on the data and insights I get. For example, I can use AWS to test different headlines, images, or layouts and see which ones perform better. AWS provides tools for hobbyists, businesses, and people that work with all sorts of data and content. Let's check out some of these tools and how companies are using them to further their businesses. As you explore the tools, see if you can identify some of the tools that Kenji mentioned. Content tools. These services help customers create, deliver, and manage content on the cloud. They include Amazon S3 for object storage, Amazon CloudFront for content delivery network, AWS Data Exchange for third-party data, and AWS Transfer Family for secure file transfer. Analytic tools. These services help customers perform various types of data analysis on the cloud. As businesses collect and need to analyze more and more digital information, Amazon can help them find data that they can act on. Some tools include Amazon EMR for processing large amounts of data, Amazon Kinesis for streaming analytics, Amazon OpenSearch service for analyzing data about how a business is operating, and Amazon QuickSight for dashboards and visualizations. Integration tools. AWS provides services that integrate content and analytic tools. These services include AWS Glue for data integration and cataloging, AWS Lake Formation for data lake creation and management, AWS Glue Data Brew for visual data preparation, and Amazon FinSpace for financial data management and analytics. Machine learning and AI. AWS provides services that enable customers to use machine learning and artificial intelligence for content and analytic purposes. These services include Amazon SageMaker for building and deploying machine learning models, Amazon Comprehend for natural language processing, Amazon Rekognition for image and video analysis, Amazon Lex for conversational interfaces, and Amazon Kendra for intelligent search. The AWS Community. The AWS community is a global network of AWS enthusiasts and experts who share their knowledge and experience with others. Select each card to examine the various community resources that AWS users can take advantage of. AWS Heroes is a group of individuals who demonstrate exceptional technical expertise, community leadership, and advocacy for AWS. AWS recognizes their contributions and provides them with exclusive benefits and opportunities. AWS community builders are emerging thought leaders who are passionate about creating and sharing technical content on AWS. They receive access to resources, mentorship, and networking opportunities with AWS product teams and AWS Heroes. AWS user groups are local groups of AWS users who meet regularly to learn, network, and collaborate. They organize events such as meetups, workshops, hackathons, and conferences. AWS Cloud Clubs are peer-to-peer groups for students who want to learn about AWS and cloud computing. They host events such as career fairs, guest speakers, and competitions. AWS Online Tech Talks are live online presentations that cover various topics on AWS. They feature technical deep dives, demos, customer examples, and Q&A sessions with AWS experts. AWS Community Day is a one-day community-led conference that showcases the best practices and success stories of the local AWS community. It features sessions from AWS heroes, community builders, user group leaders, and customers. Amazon provides a robust cloud offering with services that meet almost any need. Amazon continues to experiment with new products and undertakes research to make their cloud more robust and innovative. Explore more. Check out these resources. AWS Documentation opens in a new tab to view the latest product documentation, tutorials, and resources that users and businesses access for AWS. Get connected with the AWS community opens in a new tab to learn about the many ways AWS developers can exchange ideas and network. AWS Cloud Essentials opens in a new tab for a getting started guide to learn about the core concepts of cloud computing and the AWS cloud. The open source cloud. The major cloud providers meet many businesses' needs, but sometimes a business might want more flexibility in their cloud solution. Open source cloud platforms enable developers to review and customize the code running their platform. They can also host their cloud on their own corporate computers or on a large provider's cloud. Introduction. Imagine you have a lot of files and documents that you want to store and share with others. You could use a cloud storage platform like Dropbox or Google Drive, but what if you want more control over your data? That's where creating your own personal cloud storage system comes in. Here's where you could consider creating your own personal cloud storage system. What's involved? Step 1. Choose an open source cloud platform. You can use a free, open source platform that anyone can use and modify it to fit your needs. Some common platforms include OwnCloud, C-File, Cozy, or SparkleShare. Step 2. Install the system. Installing the cloud platform on your computer might sound complicated, but it's fairly easy. It's doable because you can install the LAMP stack. This is a set of software tools that includes Linux, Apache, MySQL/MariaDB, and PHP. Once the LAMP stack is installed, you can install the cloud platform. Step 3. Configure the platform. Before you can use the platform, you'll need to configure the platform to fit your needs. This might involve setting up user accounts for yourself and others, creating folders to organize your files, or setting permissions so only certain people can access certain files. Summary. Now that your personal cloud storage platform is installed and configured, you can use it to store and share files with others. You can also use it to collaborate with colleagues, host video conferences, chat with team members, and manage calendars and contacts. Open source cloud software. Open source cloud software has become increasingly popular in recent years. Open source licenses grant computer users permission to use open source software for any purpose they wish. There are various tools available in the open source community for building a personal or company cloud. Developers typically deploy open source clouds on personal or corporate-owned computers. These are private clouds and only the individual or members of the corporation can use them. While users can create private clouds on their own servers, they can also create them on clouds hosted by big cloud providers like IBM, Amazon, and Microsoft by using private networks, such as Nextcloud, OpenStack, OpenShift, and Eucalyptus. Select each tab to learn more about some open source cloud networks. Nextcloud is an open source cloud storage platform that enables users to store and share files, documents, photos, and other data. It also provides a range of collaboration tools such as video conferencing, chat, and groupware. OpenStack is an open source cloud computing platform that enables users to build and manage private and public clouds using pooled virtual resources. The platform is made up of several projects that handle core cloud computing services such as compute, networking, storage, identity, and image services. OpenShift is a cloud development platform as a service, PaaS, hosted by Red Hat. It's an open-source cloud-based platform that allows developers to create, test, and run applications in the cloud. OpenShift can manage applications written in different languages such as Node.js, Ruby, Python, Perl, and Java. Eucalyptus is an open-source software platform for implementing infrastructure as a service, IaaS, in a private or hybrid cloud computing environment. It is compatible with Amazon Web Services, AWS, enabling users to build AWS-compatible private and hybrid clouds. Eucalyptus enables users to provision compute and storage resources on demand. There are many open-source tools available for building a private or even public cloud. As with all open-source software, the products that a person or business chooses will depend on the features the software makes available, how big the community is that supports it, and other factors such as compatibility with other systems, hardware requirements, and ease of use. About this module. Module 4. Scenarios where service models are appropriate. Introduction. This module walks through scenarios in which companies use the three primary service models so you can better understand the value and when to use cloud-based software with SaaS, scale infrastructure with IaaS, and deploy projects with PaaS. Learning objectives. After completing this module, you should be able to recognize the value that businesses can expect when using software as a service, SaaS. Differentiate between scaling up and scaling out an infrastructure. Recognize the value that businesses can expect when using infrastructure as a service, IaaS. Recognize the value that businesses can expect when deploying apps using platform as a service, PaaS. Cloud service models. Cloud service providers like IBM, Microsoft, and Amazon design their services so companies and individuals not only can build their own software solutions, but also use the cloud software and services that the cloud providers make available. There are three primary types of cloud computing services that meet specific needs. Software as a service, SaaS, enables people to access software applications over the Internet. Infrastructure as a service, IaaS, provides virtualized computing resources over the Internet. Platform as a service, PaaS, provides a platform for developers to build, test, and deploy applications over the Internet. One of the advantages of cloud computing is the ability for users to pick and choose what software and services they'll use based on their needs. For example, a single user or small company might only need to use a productivity suite of software tools, so they might use a SaaS offering. A medium-sized company might not want to manage their own infrastructure for their business, so they take advantage of an IaaS solution on the cloud. A hobbyist might need a website and use the cloud to host and deliver a scalable website using a PaaS offering. Next, you'll get an overview of different scenarios for each of these cloud service models and when people use them. As you explore these topics, think of companies you know or ways you could use cloud services for your hobby, side job, or business needs. Empowering companies small and large with SaaS. There are many cloud-based software packages that people can use for a variety of tasks. Miro is a popular visual collaboration tool. People use Lucidchart and Google Drawings, two cloud-based tools for creating diagrams. Even graphic design tools such as those found in the Adobe suite use a mixture of desktop software and cloud-based services to power their tools. Cloud-based office productivity tools such as those used to create documents, spreadsheets, and presentations are popular among businesses and individuals. Google, Microsoft, and Kingsoft all use cloud services to power their suites of tools that users can access from a web browser. Introduction. Investigate the following story to discover why a small company might turn to cloud software for their business. Step 1. A small company is struggling to keep up with the costs of their IT infrastructure. They're looking for ways to reduce their costs and improve their productivity. They've heard about cloud-based office productivity suites and are intrigued by the idea of having a cloud-based central location to operate without expensive infrastructure. Step 2. The company decides to research different solutions to reduce their costs and improve their productivity. They come across cloud-based office productivity suites such as the Microsoft Cloud-based Office 365 suite and WPS Office, which is a small-sized office suite that features only 4 apps: Writer, Spreadsheet, Presentation, and PDF. Step 3. After evaluating different options, the company decides to move to WPS Office Suite because it reduces their IT infrastructure costs and provides a better way of sharing the files their employees create. The suite of tools also enables employees to work on files at the same time, improving collaboration. The employees can work remotely, which is vital for productivity and data security. Step 4. The company implements WPS Office and trains their employees on how to use it. They monitor and evaluate the effectiveness of the cloud-based tools. They find that it helps them accomplish their goals. They can keep their employees connected and support easier collaboration when employees work on documents, spreadsheets, and presentations. Summary. Notice that the cloud-based productivity tools in this story helped the company solve several challenges. Costs. By moving to cloud-based software, they were able to reduce overall costs on their IT infrastructure. Productivity. The ability to access both software and files from anywhere helped the company's remote workforce become more productive. Collaboration. Many cloud-based productivity tools enable people to work on documents and files at the same time and easily share files with others, making collaboration simpler. While these solutions are powerful for a small company, the advantages that cloud-based productivity tools provide apply to large companies and individuals in just the same way. Whether for a small company or large company, there are many advantages to the businesses and people who use cloud-based productivity tools. Software as a service, SaaS, can potentially reduce costs, increase productivity, and promote collaboration. Building a business that scales using IaaS. Consider a financial services company that is growing rapidly. They provide financial services to their clients and their business is expanding. They realize that they need to scale their financial services infrastructure to meet the growing demand of their clients. In a traditional computing model, they would need to upgrade their existing infrastructure or purchase more computing resources like servers and hard disk drives to keep up with the growing demand. But, by using IaaS on the cloud, the company can scale their operations by scaling up or scaling out. Scaling up. Scaling up refers to making an existing resource larger by integrating resources into them. This is done by adding more memory, CPUs, or storage to an existing server configuration to address a specific problem. Typically, a configuration can't automatically scale up. A user chooses to scale up by selecting a new configuration which the cloud provider then implements. Scaling up is also known as vertical scaling. Resources on the cloud, like a web server, typically reside on one or more physical computers or virtual machines. Cloud providers have computers and virtual machines in a variety of configurations to meet various customer needs. Memory. The memory on a system is an important factor in how the system performs. When users set up a service on the cloud, they specify how much memory they want their system to have. If a user needs more memory, they can choose to scale up to a configuration that supports their need. Storage. Many cloud scenarios use specific computers for data storage so the data does not reside on the same computer or virtual machine as other resources. When scaling up, users can specify how large they would like their storage to be and set limits to how large it can grow, or shrink. Typically, users set their storage limits in gigabytes, GB. CPU/vCPU. When scaling up, users can choose how many CPUs they want their physical computer to have or how many virtual CPUs, VCPUs, they want their virtual machine to have. Scale amount. When setting up an IaaS environment, many cloud services will set a limit on how many machines or virtual machines a user can have for their given configuration. For situations that will demand a heavy workload, it's important for users to choose a plan that will allow for a lot of machines to be created. Scaling out. Scaling out refers to creating one or more copies of a resource to share the workload. The resource might be a physical computer or a virtual machine. The copy will have the same configuration as the original resource and be capable of performing the same tasks. Scaling out is also known as horizontal scaling. Imagine that a person worked as a copywriter for 10 years and learned how to do the job really well. One day, the senior manager walks into the editor's office and says, "Our copywriter is so skilled at their job. I wish I had 5 of them." They both smile and then the editor says, "Oh, you haven't heard? It's now possible to copy humans. You just pay a small fee and you can copy anyone you like." Although it's not possible to copy humans, it is possible to make copies of cloud resources. Having more than one copy of a cloud resource that does a lot of work can be a very good thing. Creating instances. When a user or company wants to scale out a resource like a virtual machine or even a physical computer, they specify the maximum number of computers of a given configuration that the cloud service will create. Each computer that has that configuration with all the software and services running on it is called an instance. Cloud IaaS software monitors the performance of applications and, when necessary, it can create new instances by replicating the computer configuration to ensure people using the applications have the best experience. Users can configure their system to create instances to accommodate demand or at a specific time. Review the following 2 scenarios to learn more about the ways companies can use cloud scaling to keep their products and services performing at their best. Scenario 1. Scaling out to accommodate demand. ABC Media is a company that provides promotional services to new companies. Review its process to learn how ABC Media uses cloud services to scale out to meet demand. Step 1. ABC Media signs up a startup company called Nice Hands that sells hand lotion. For a short time, Nice Hands is giving away a small bottle of hand lotion to everyone that signs up to their mailing list or that promotes them on social media. Step 2. Based on experience, ABC Media expects a certain number of sign-ups during the promotional period and sets up their cloud service for the promotion to handle the expected traffic. Step 3. ABC Media also has a scale-out contingency in place where its cloud service can scale out to handle 4 times the web traffic if need be. They set up a rule that each time traffic increases by 25%, their cloud provider will deploy a new instance of their service. The rule also states that it should deploy no more than 5 instances in total. Step 4. Shortly after Nice Hands opens for business, a celebrity discovers the hand lotion and loves it. The celebrity tells others about their love for the product on social media. Step 5. Because of the celebrity's endorsement, the sign-ups for the hand lotion increases dramatically over a period of 3 days. Step 6. Because of the scale-out feature of ABC Media's cloud service and the rules they put in place, the sign-up service scales incrementally as traffic increases and can provide a great customer experience during the promotion period. When the promotion is over, the service scales back down as traffic decreases. Scenario 2. Scaling out at a specific time. A university deploys a cloud service to empower their library to give students better access to research tools. The service enables students to search large databases for books, articles, journals, and papers on every topic the university teaches. Review its process to learn how the university uses cloud services to scale out at specific times. Step 1. The university examines historical data from its physical library about when students check out books, make copies of articles, and use library services to find information. Step 2. The university uses several years of data to create a typical baseline for when students use the library and its services. They use that baseline to chart peak use and when usage is lower. The analysis shows that library usage peaks, lowers, or is typical at the same times each week. Step 3. They find that weekends tend to be lower usage, Mondays and Tuesdays tend to be peak usage, and Wednesday through Friday tend to be typical usage. Step 4. When the university transitions some of its services to the cloud, it includes a scale-out rule that matches the usage patterns in the library. The service automatically scales out instances on Mondays and Tuesdays, reduces the number of instances Wednesday through Friday, and scales instances back on weekends. Step 5. The scheduled scale-out enables the university to save infrastructure costs by having only the server instances they need when demand is low. At the same time, they scale out when most students need the service, thus ensuring that the library can meet demand. In both scenarios, the cloud customers support their users by scaling their services to meet demand. ABC Media scales out based on demand because the demand is unknown ahead of time. The university uses data to determine when and how much to scale their services, making their costs more predictable. And, in both scenarios, the cloud customers can manage their costs by only paying for the additional infrastructure when user demand requires it. You can see how valuable it can be for businesses to use infrastructure as a service, IaaS, to scale up and scale out their infrastructure on the cloud based on needs or even events they cannot foresee. Deploying solutions with PaaS. In the early days of the Internet, if a company wanted to build a website, they hired specialists to write HTML code and then publish the code to a web server that was, by today's standards, rudimentary. Today's cloud enables companies and individuals to deploy a website with just a few clicks. After deploying the website, they can use the site as is or extend it by creating new templates, developing software, and analyzing the website and user data. The cloud provides the entire platform that companies and individuals need to build and deliver software and websites. This is known as Platform as a Service, PaaS. Using PaaS to deploy a website. First, people who don't have technical skills can easily create a website using an open-source platform like WordPress. It is a popular, easy-to-use content management system, CMS. A CMS enables users to create and publish website content, including blog posts, images, videos, and other multimedia. Then, Microsoft Azure enables people to deploy a WordPress website with just a few clicks. The deployment includes the web server and associated services on which to run the platform, the database the platform needs, a virtual network to make the platform more secure, a content delivery network to make delivering media like images more efficient. Microsoft Azure has a PaaS offering with all the components needed to make this happen for someone deploying a WordPress website to the cloud. Using PaaS to develop and deploy a software solution. Suppose a company wants to develop an application to help people find the best restaurants in their city. They have a great idea for an app, but don't have the resources to build it themselves. And they need hardware and software tools to develop their application. PaaS is just what they need to develop and deploy this helpful app. Application development. The company uses PaaS to develop their application without having to worry about the underlying tools and services they need to develop the software. They use PaaS for microservices, various environments, database hosting, business analytics, communications, internal tools, and private dashboards. API development. The company wants to enable other businesses to use their service. They want to create an API that developers can use to get and send data from and to the company. The company uses PaaS to develop their APIs, which are an essential component of any modern distributed application. The built-in frameworks that PaaS provides greatly simplify API development and management. They also use PaaS for microservices that are complementary to PaaS and a great aid in deployment. Testing. They use PaaS to create different environments with different operating systems and form factors which enable them to test their application in those environments before deploying it to users. Securing data. They use PaaS for database hosting, which enables them to store their data securely in the cloud. Analytics and communication. The company uses PaaS for business analytics, which helps them analyze data from their application and make informed decisions about how to improve it. The PaaS platform also has services that enable the company to communicate directly with its users through various channels such as email and push notifications. Internal tools. Finally, the company uses PaaS services for internal tools and private dashboards which allow them to monitor the performance of their application and make sure it is running smoothly. By using the tools, services, and frameworks that PaaS provides, the company successfully develops and deploys their Restaurant Finder app. You can see how valuable Platform as a Service, PaaS, can be for businesses and developers, from start to finish, to build, test, secure, deploy, and analyze applications on the cloud. You've come so far. You got an overview of how the cloud supports and powers new technologies like AI and IoT. You learned about the 4 main types of cloud service models and 2 types of software approaches when it comes to cloud solutions, proprietary and open source. You explored the services offered by the major cloud providers, IBM Cloud, Microsoft Azure, and Amazon Web Services. And finally, through some scenarios you learned about the advantages and value businesses and individuals can expect when they use the various cloud service models. Now that you've completed this course, you should be able to describe the characteristics of various cloud service models, including IaaS, SaaS, PaaS, and DBaaS. Differentiate between proprietary and open source approaches for developing cloud solutions. Identify the services and differentiators of the major cloud providers. Identify scenarios where various cloud service models are appropriate to use and recognize the value that businesses can expect from them. Key points to remember. 1. AI technologies provide many useful features of modern life, including medical diagnoses, virtual assistants, chatbots, and fraud detection. 2. The cloud enables AI technologies by providing data storage, processing power, and connections. 3. The IoT is a networking model that describes the interconnection of physical devices that owners can access and control through the Internet, and the cloud is crucial for storing, processing, and analyzing the vast amounts of data generated by IoT devices. 4. There are 4 types of cloud service models. SaaS delivers software applications to users over the Internet. IaaS provides access to computing resources like servers, storage, and networking over the Internet. PaaS enables users to develop, run, and manage applications over the Internet. DBaaS provides users with access to fully managed databases. 5. Proprietary software is software that a company or individual owns and controls. 6. Open source software is software that developers, often collaboratively as a community of programmers, create and distribute under a special type of license. 7. The source code for open source software is available for users to access, modify, and distribute alongside their own code. 8. Most cloud providers have a global presence with strong security, reliability, and scalability. They offer standard services such as IaaS, SaaS, PaaS, and DBaaS. 9. The major cloud providers IBM Cloud, Microsoft Azure, and Amazon Web Services, AWS, also offer services that differentiate them from each other. 10. Open source cloud software enables developers to create their own private clouds on personal or company computers.